Hey guys, my name is Trivoxel. Obviously not my real name, but today I'm going to be showing you guys how to get GPU rendering working on Fedora. Now, why Fedora? Well, okay, Fedora is like one of the most popular Linux distros out there right now. Let me tell you, it's hot, okay? In case you're wondering what my specs are in this video, I've got them all right here. I'm going to be showing you guys how you can get GPU rendering working in Blender cycles today without any hassle. A lot of people think that in order to get GPU rendering working in Blender with AMD graphics, it's a lot like NVIDIA, where you got to use the proprietary drivers and hassle with that. And trust me, trying to get those working on Fedora or anything other than Ubuntu pretty much is a joke. So we're not going to be doing that because it's completely unnecessary, okay? I'm going to have chapters in this video, by the way, so, you know, you can just pop over to whatever section interests you the most. Probably the installation if you're an actual professional, but for the more casual audience, I'm just going to talk about kind of the differences, the changes that's happened in Blender for making this way easier than I think anyone has realized. So, if I take a quick gander at the internet here, alright? I'll look up how to use GPU render in cycles on Fedora, for instance, okay? So here we go. Result from 2022 and talking about recompiling stuff and error codes and all that fun stuff. You know, this is probably the most relevant forum post I can find, okay? You'll find all sorts of dead ends trying to figure this out, and a lot of people trying to use the proprietary driver, and that's just no good, okay? That's not necessary. It's not how we like to do it. So if you just rewind time a little bit back to Blender 2.93 and everything before that, GPU rendering on AMD was done with OpenCL, and boy howdy, that was pretty awful, okay? Let me tell you. It was kind of slow, kind of buggy, kind of a pain in the ass to set up. You had to use the proprietary driver. Dare I say anymore, okay? It was no fun, and setting up OpenCL rendering on AMD would absolutely mess up something with your gaming setup. It was just not ideal. So that was dropped starting with 3.0, and they started using HIP, which was something that AMD made themselves. Anyways, that's basically where we're at now, so no more dealing with this monstrosity, okay? I'm on the AMD driver support website here, and let me tell you, unless you're on Ubuntu LTS or Red Hat Enterprise Linux, which I'm gonna guess most of you guys aren't, it's not gonna be that helpful for you, and even if you were, not really where you want to be, okay? So that's basically how things are now. So I'm gonna show you real quick in the tutorial part of this video how to actually install it, because it's not as hard as people think it is, okay? I'm gonna blow your minds right now. So let me just go ahead and open up my terminal. In this case, it's called console. And yeah, I'm just gonna do a sudo dnf install rocm-hip and hit enter. It's gonna ask you for your password because we're on Linux, and I already have it installed, as you can see. You know, I don't want to uninstall it and reinstall it for the video, but that's all you gotta do. And then don't forget to reboot, you know? And then after you do that, it's gonna load in that HIP module, and you're off to the races. That's all you had to do to get GPU rendering working on Fedora. Super easy. Don't know why that's nowhere in the Blender documentation or AMD's own documentation, and I've read through their documentation. Maybe it's changed recently. I haven't read it for a while, but that's all you have to do. And now that you've done that, you can actually use GPU rendering. Now, there's a caveat, okay? The most popular way to get software on Linux is by far using FlatHub these days. It's a nice medium, but unfortunately for Blender, let me show you what happens when you try to use this. Ooh, no HIP support. What the heck? I just installed the HIP module. Unfortunately, the Flatpak version just doesn't seem to support GPU rendering, at least on AMD, but probably at all. And This is not a permissions issue as far as I know, because this nifty little program called FlatSeal, don't know if you've heard of it, but it's pretty synonymous with Flatpak these days, and basically it lets you override the permissions for these sandbox Flatpak applications. So, you know, you can force an app to have certain permissions, which is something that you can't really say of other platforms. But hey, I have just gone ahead and let it do anything that it wants to my computer, and even with full permission to all of my devices and my shared memory and virtualization and, you know, the dbus, there's just no sauce, guys. Sorry, I'm just not going to be able to do it. If you're okay with EV and CPU rendering, then you're fine. But for everyone else who wants GPU rendering on their expensive graphics cards, that's probably not going to cut it. So, solution is to go back to the old days of the traditional packages, okay? No fancy security stuff, but I don't think anyone's going to be hacking your Blender, so you should be okay. I'm going to open up Blender here. Look silly because I didn't set up my my edit menu preferences shortcut, but hey, if you use the regular package, as you can see, it picks up on the graphics card just fine, and I can set that up there. And you're not just limited to what's in the repository, because it's one of the benefits of something like Flatpak, right? You get the nice up-to-date stuff and you can choose branches and whatnot. Well, fret not, okay? We've got you covered. So if you're trying to do this and you use like a different version, so you want to use the alphas or an older version for your projects or something like that, right? You can just go ahead and as you can see, I got the latest version from builder.blender.org/download. Pretty nice resource. And then blender.org/download, you can get the LTS version, or and I'm gonna open up the latest alpha version here, and I do have GPU rendering. So these, like the system application, are not confined by any kind of sandbox, so they can access the GPU driver just fine. And yeah, now I can do some GPU rendering. Now, I'm actually gonna do something interesting for this, because I don't know if really anyone in the Linux community has done this yet, but I'm going to go ahead and benchmark each of these demo files. Okay, we've got the classroom, classic, you know, Cosmos Laundromat, another classic, I'm pretty sure. Avalon Barcelona, you know, pretty sure I misspelled that, but hey, you know what? Got that in here too. Barbershop, Scanlands, and the Junk Shop. Okay, I'm gonna be rendering all of these on my CPU, then I'm gonna render them on my GPU, and then I'm gonna render them on both of them. We're gonna compare the speed difference, okay? And this kind of represents the best case scenario for AMD right now, so I'm hoping it's good. I don't have any idea how this is gonna turn out, but I got the 7900 XTX, which is kind of the cream of the crop from AMD, so let's hope that it's not extremely pitiful. And I'm gonna show you the results after a quick, like, cutaway edit thing.
And now, for the moment you've all been waiting for.
Yes, I actually rendered all 7 of those demo files I mentioned. One of them I maybe didn't mention, but hey, I rendered all of them on my CPU, my GPU, and on both of them together, as I promised. And I even made like these really low resolution charts that I am too lazy to upscale. So let's start with our first render here, the classroom render, which is a classic, let me tell you. Okay, this thing's been burning up CPUs and GPUs for some amount of time that's measurable, okay? So anyways, the CPU on this one took about 336 seconds. The GPU only took 21.5 seconds. And both of them combined actually took 25 seconds. Cosmos Laundromat scene took my CPU 625 seconds, the GPU took it 128 seconds, and both of them combined took 135 seconds. Now moving on to Barcelona. CPU render takes 387 seconds, GPU takes 39 seconds, and both of them combined is 40 seconds. Now moving on to Barbershop. Okay, this is a pretty wicked scene, and it took my CPU almost 10 minutes. I mean, 1,447 seconds, and the GPU only a mere 97 seconds. Wow. and then both of them 299 seconds, which is not really that great. And then we're gonna go on to Scanlands, okay? So Scanlands took my CPU 829 seconds, and my GPU 123 seconds, and both of them combined. Actually, surprisingly, it only took it 15 seconds, which is actually surprising. You know, usually putting them both together at bottlenecks the GPU on my system, so this was actually a bit of a surprise to me. Junk shop here. CPU only took 58 seconds, which is pretty impressive actually. It just goes to show how much Blender's renderer has evolved with CyclesX and with the adaptive sampling and stuff. A lot of these scenes are really old, so they don't use the adaptive sampling, so it just samples everything equally, which takes a really long time, and this really does show you how much better it's gotten for people who only have CPUs. But anyways, I digress, you know. 58 seconds on my CPU, not really that great when you compare it to the 16 seconds it took my GPU to render this thing, and then combining them get 23 seconds, not too bad. And then the BMW scene, you know, classic, everyone loves the BMW scene. It's been around for ages and benchmarked on almost everything. Took my CPU 145 seconds to render, and my GPU only 12 and a half seconds to render, and then both of them combined was 14 seconds. And now I've got the grand total, so I just put them all in one big huge chart just for fun so we can compare them all kind of in the big picture. As you can see, by far the CPU renders just take so long when compared to the GPU renders. Combining, in the one case the Scanlands was better, but on my system it definitely bottlenecks the GPU. I'm guessing that the GPU finishes things up pretty nice and cleanly, but adding the CPU on there, you know, it's taking up portions of the rendering that the GPU would be faster at, and it's actually just causing those to take longer to render than if I just let the GPU render it all. And, you know, maybe if I were to have like a crazy dual socket
Threadripper overclocked with liquid nitrogen cooling and 128 terabytes of RAM and an NVMe Gen 5 SSD.
you know, maybe then like it wouldn't be so bottlenecked, right? And the CPU would be able to hold its own. And I imagine that actually on scenes that are like 8K or something, where it takes so many tiles to render everything, I bet on those scenes they would be a lot faster, but I don't have the data to back that up. That's just my guess. But anyways, yeah, as you can see, my Ryzen 5 7800X 3D is nothing compared to my fancy, shiny new Radeon 7900 XTX, which I am very glad because it's not a cheap GPU, but man, do I feel like it was worth it when we go ahead and look at the tally at the end here. And I swear, I'm almost done, okay? Video's almost over. So, we take the totals, okay? The grand total render time for all of these was just under 1.5 hours. Way better than I was expecting. You know, I was expecting this to take like 3 or 4 hours, so pretty happy with that. The average render time for the CPU was 547 seconds, and then the average render time for the GPU was 62.5 seconds, and the average render time for the CPU and GPU combined is 93 seconds. And yeah, when I crunched the numbers, turns out that the GPU is about 89% faster than the CPU. 89%. I mean, might as well call it 90%, right? 90% faster than the GPU, or 90% faster than the CPU. That's absolutely wicked. And then the CPU plus GPU combination, again, in my case, it's going to be very case specific, but you know, with my CPU and GPU combination, ended up being 83% faster, which is still a lot better. And as you see in the Scanland scene, obviously some scenes are going to benefit from it, and I'm going to imagine it's mostly the higher resolution renders that are going to benefit the most from it, where they have just so many tiles it would overwhelm one or the other. But I'm pretty sure I'm done with this video, guys. I hope that you liked it.